Okay, good afternoon, class. I don't see anybody in the chat room right now, but I'm going to go ahead and get started. We're going to go over 3 more sections in Cycle 2, 2.7, 2.9, and 2.10. So let's take a look at 2.7. And this section introduces the distributive property. And if you remember, the distributive property is the property that allows us, when we're using order of operations, to remove our parentheses. So if we're going to distribute here the factor of A, and we want to distribute it over B and C, to remove the parentheses, we multiply each item inside of the parentheses that are being added or subtracted each term by the constant or the term that's on the outside of the parentheses. So we can distribute multiplication over addition, and we can also distribute multiplication over subtraction. And so let's take a look at a couple of problems. So let's take a look at this first problem. We're going to go ahead and distribute. In order to remove the parentheses, we need to distribute the -3 to each term within the parentheses. So we're going to get -3x squared. -3 times -4 gives me a plus 12x, and then -3. On this problem here, we could distribute, or we could also simplify inside the parentheses first. But let's go ahead either way. So we could first do -4 this becomes 16. Oh, this doesn't look like the right answer. I apologize. It should be a -1 out in front. I'm sorry. I'm just looking at this problem saying that's not giving the right answer. There should be a -1 out here. I apologize. So you could distribute the -1, which would make both of these positive, or you could simplify inside the parentheses and then distribute the -1, and the answer is 11. Okay, down here we're going to distribute the 10x, and we get 10x cubed. Remember exponent rules. We add the, when we're multiplying terms with the same base, we add the exponents, minus 50x squared plus 60x. And a few more. Distribute here. It doesn't matter if we're distributing from behind on the right side of the parenthesis or on the left side. Same process. 2 times 8 is 16 plus 2x. Here we're going to distribute and then combine like terms. So if we go down below here and we distribute first, what do we get? We get 12. And then we're going to have minus 8i. And then on the second part, we're going to get plus 48. Minus 6i. Alright, and then we want to go ahead and combine like terms, so we're going to have two constants here, so we're going to end up with 60 minus 14i. And then down here, again, we're going to go ahead and distribute, and then we're going to combine like terms. So if we go down below and we distribute, and I'm going to type it down here, so 2 times 6 is 12x, and my exponent is going to be to the 4th power. And then I have minus 8x squared. And then I have plus 22x. Oops, x. And then on the second distribution, I'm going to do minus 5 times x gives me minus 5x, and then minus 45. And then I'm going to go ahead and I'm going to look and see, do I have any like terms? And I actually don't. Let me see. 1, 2, 3, 4, 5. Do I have any? 12x to the 4th minus, I think I have 2x terms. I do. 22x and minus 5x here. Yeah, so that's going to be plus 17x. So there's two that I can combine. Let me get my pencil so we can see those. So we have this term and this term are both x terms, so they get combined. When we simplify, and we get plus 17x. The other terms are the only terms, so we can't combine those. So the distributive property is an important property in often used in mathematics, and we have to be able to understand it and not to apply it carefully. Understand the distributive property only applies when you have a sum or a difference in the parentheses. So for instance here, we can multiply a binomial times a binomial, and there's a couple of ways to work this problem. The first way is distributing the quantity x plus 2 to both the x and the 3 inside the second set of parentheses. So when we do that, we get x times x plus 2 plus x plus 2 times 3, and then we distribute a second time. So we get x squared plus 2x 3x plus 6, and then we combine the like terms, the 2x plus the 3x, to give us 5x. And there we go, step by step. Another way you can work when you're multiplying two binomials is to use FOIL, first, outer, inner, and last. This method organizes the four products by their location. So FOIL says first times first, so we get an x squared. Outer, 3x, inner, 2x, and then last, 3 times 2 is 6, so we have these, and then we go ahead and combine the like terms, and we get the same answer that we had before. The other way you can use is the box method, and some students like to use the box method, where you go ahead and you create boxes with the terms here, and then you go ahead and do the multiplication. So x times x is x squared, x times 3 is 3x, 2x, 6, and then add up the terms in the boxes and then collect the like terms. Let me go back for a second. If you had negatives here, you would have to remember to put that negative as part of the term that's above the column or in front of the row, so you want to watch your signs. Okay, so let's try a couple here. We're going to FOIL, so I'll do FOIL on this one, so I'll get x times x is x squared. I might have some steps on this one. No, I don't. Okay, so x times x is x squared. Outers gives me minus 8x, minus 2x gives me minus 10x, plus 16. All right, on this one, you're going to go ahead and distribute the x plus 1 times the first term, times the second term, times the third term. And notice you'll have 6 terms when you do that. Let me type it down below. So I'm going to get x plus 1 times x squared minus, notice the minus, and I'm going to put the x plus 1 in the front, whoops, x plus 1 times 2x, and then I have plus, and I just have a 1 times the x plus 1 on the last term, x plus 1. All right, and then we can go ahead and simplify. Let's distribute again. So the first expression there, I'm going to get x cubed plus x squared minus 2x squared minus 2x plus x plus 1. All right, and then we look over here for some like terms, and we see some of the same terms here, don't we? We have an x squared, and we have an x squared and an x squared. We have an x and an x. And if we go ahead and combine like terms, we end up with x cubed minus x squared minus x plus 1. Okay, section 2.9, using operations correctly. And in this section, we introduce the concept of operators and objects, which is similar in language to how we use verbs. Operators are going to be verbs, they do things, and nouns, which are the objects, and those are the things to which we do the operation. In mathematics, we often interpret operations as actions that are applied to the numbers or the expressions. Operations are active, they do something. Numbers and expressions can be seen as the objects to which the operations or actions are applied. Understanding what operation is being applied is essential, especially when we get into solving equations. It's interesting for you to think about that. There's a nice table in your book here, and what they do here, and you have some homework like that, they give you an expression and they tell you either the object or the operation, or possibly they give you the object and the operation and say, give me the expression. So if we look at this expression, the object here is 17, and what are we doing to it? We're taking the square root. So let's look at the next expression, 4 and 2/5. So the objects they've identified are 4 and 2/5, and how do they go together to create this expression? They're added together. The next expression is 8 over 9, so how are the objects combined here? It's a division. Here we're taking an operation of an absolute value and we're applying it to what object? The negative 10. Here we're squaring the negative 8. Notice the difference between E and F. In F, the base is just the 8, so we're squaring the 8. In G, we're multiplying 2 times, the other object is x plus y. Here we're adding A and B. In this one, we're dividing the numerator and denominator. And here we're adding 2 fractions, and finally the division here has actually 2 parts to it. All right, and then there's the completed table. So parentheses affect the value of an expression in much the same way punctuation affects the interpretation of a sentence. The meaning of these two sentences are very different with the addition of the commas. I like cooking, my family and my dog. Notice no comma here. It sounds like you're going to cook your family, maybe cook your dog. If we put a comma right here and also in front of the and, it makes a whole lot of difference. It says you like three things. You like cooking, you like your family, and you like your dog. And that's what parentheses help us to do in algebraic expressions. So for instance, if we have this expression here, if we put some parentheses in, it changes the entire meaning of the mathematical expression. This is negative 16, this is 64. So by adding the parentheses, we have a difference here, and here we have a product. So a parentheses can tell us a lot. So it's necessary to distinguish between the operations of subtraction and multiplication in those above expressions. And similarly, the distinction between operations and objects is essential for using the distributive property correctly. In the following example, the operation of multiplying 3 is applied to each of the objects or terms in the parentheses. So we're distributing, sorry, this is over here. 3 times 2 gives us 6x, 3 times 9 gives us 27. We're distributing the factor of 3 to both of the terms in the parentheses. In contrast, if we have an expression like this, 3 parentheses 2x times 9, we can't distribute the 3 because there's only one term in here. There's not an addition or a subtraction inside. It's simply one term. And so we just multiply the coefficients, 3 times 2 times 9, and then keep the x. So you want to make sure when you're working a problem, you understand the difference between whether the expression in parentheses is being added or is it simply being multiplied. So let's try this example here. We want to simplify. Notice that the operation of division by 4 is being applied to the sum, and we can use the fact that division can be distributed over a sum to simplify it. Okay, don't just cross off the 4s because you're not going to get the right answer. So now if we go ahead and break it into two fractions, we have 4x over 4 plus 1 over 4, which simplifies to x plus 1/4. And if you just cross out those 4s, you're going to miss the fact that the 4 is being divided into the 1 also. Now let's try these. Okay, so again, if you divide it into the two fractions, 7x over 7 plus 7 over 7 is going to give us x plus 1. In this case, we'll divide it into the two fractions, x over 7 minus 7 over 7, so we get x over 7 minus 1. And then the last one, we can go ahead and distribute the negative across the terms in the numerator. So I get negative x over 7, negative and negative gives me plus 7 over 7, and so I have negative x over 7 plus 1. Evaluating expressions is something we're going to cover in this section. So they're going to give you an algebraic expression and then give you a value for the variable or values for the multiple variables and say evaluate when x equals, or in this case when n equals. So then we want to also give the operations that contain the inverse operations in the reverse order of the first list. So let's see, what do we do here in order to evaluate it? First we're going to square, multiply by 3, and then subtract 2. So when we do that, opposite would be add 2, divide by 3, and take the square root. And so what do we get for an answer? We're going to put in n equals 5. So the first thing we're going to do is square the 5. 25 times 3 is 75 minus 2 gives me 73. Okay, same thing on this one. What do we do first? First thing we're going to do is subtract 1. Once when we're evaluating, we have a value for n. Then we're going to multiply by 2 and finally divide by 3. The opposite operation, multiply by 3, divide by 2, add 1. And when we do that, we're going to get 2 times, and it's going to be 5 again. 5 minus 1 is 4. 4 times 2 is 8. 8 over 3 is our answer. Okay, and then the last section we're going to do this week is 2.10, which is looking at solutions for equations. So we're going to solve some simple equations here, and the solution is a number that results in a true statement when it's substituted for the variable in the equation. Let me just go back for a second. At the end of the last section, when we're doing evaluating, we're only working with expressions. Okay, so we're finding out what they equal when we put in a certain value for the variable. And we can use multiple values when we're evaluating expressions. When we're doing equations and solving them, we're going to come up with one of three possibilities. One is we find a solution. So let's say we're going to check a solution. So they said x equals 3 is a solution to this equation. So when we substitute in x equals 3, we replace x with 3 on both sides. Go ahead and simplify. We end up with a statement here that's always true. 1 equals 1. So let's try for each equation, verify that the given value is a solution by checking it, by substituting in and checking that we get a true answer. So I'm going to go ahead and substitute in for x a 3. So 3 times 3 is 9. 2 minus 9 is negative 7. Does that equal negative 7? Yes. So x equals 3 is a solution to that equation. Let's try this equation here. We're going to let x equal 2. So I'm going to put in 2 for x. So I've got 2 minus 1 is 1, and then I've got 14 minus 4 equals 10. 10 equals 10. This is a solution. One last one here. X equals 5. I'm going to substitute 5 in. 5 times 2 is 10, minus 1 is 9. On the right-hand side, 8 minus 5 is 3. Is the square root of 3 equal to 3? Yes. X equals 5 is the solution to that equation. And another one. We're going to let x equal negative 2. Negative 2 squared. Now remember, this is my base, and I'm going to square it. I'm going to get a 4, but the negative that's outside of the parentheses comes along. And then I've got 5 times negative 2 is negative 10. Negative 14 plus 14 equals 0. 0 equals 0, so that's a solution to that equation. And one more. So we're going to let x equal 4. So 2 to the 4 minus 1 or 3. 2 to the third power is 8. 8 minus 8 is 0. It checks. That's a solution to that equation. So to verify a solution, substitute the value for the variable into the equation, simplify the left and the right. If a true statement results, the value is a solution. If a false statement results, the value is not a solution. So use the following algebraic equation to answer the questions. Simplify each side. What do you notice? So we're going to go ahead and simplify each side of this equation. And when we simplify it, we end up with exactly the same expression. And again, we could go one more step and add 7x to both sides, and then we get 11 equals 11. But when we get the exact same expression on both sides, okay, let's keep going for a second and then we'll answer that. Confirm that x equals 1, x equals 0, and x equals 4 are all solutions to the equation. Okay, so if you do that, you'll find out that you always get a true statement. And you could pick any other number and you'll also get a true statement. So what does this tell us? The solution to this equation is all real numbers. The left side is identical to the right side, and both sides are defined for all real numbers, so every number is a solution, and we call this type of an equation an identity. So no matter what I put in here for x, I will always get a true statement. Each time we contain the same terms when it was simplified, when we always end up with a true statement, it becomes an identity. If we end up with a statement that's not true, let me go back for a second to this one slide here where we said both sides came out to be the same. If this had come out to be this side and then on the right side was plus 12, that would be called a contradiction, and the answer would be no solution. So again, when we're solving an equation, these are linear equations, one of three things can happen. We have a solution, a single number that makes a true statement of the equation. We have all real numbers as solutions. Or we have no real numbers, no solution, which is, and again, all real numbers is an identity. No solution is called a contradiction. And again, next week we'll be doing more solving, so you'll see these things occur again. So have a great week, and hopefully this quick little review will help you with your homework for this week.